Alright, so we're going to be going through some of the problems on this worksheet 2 so you guys understand how to do these proofs and stuff. So we have this given is that KYT is congruent to KHT. These two triangles are congruent. So these two triangles are congruent. So that means that everything about these two triangles are congruent. So KYT and KHT are congruent. So we'll write that up there. KYT is congruent to triangle KHT as given. Alright, so now I'm looking to see, and I need to prove that YKZ is congruent to HZK. Right, that's kind of messy. Okay, all right, so these two small ones, we're given these two small ones, and I'm trying to prove these two larger ones. All right. So first thing I'm looking at is what is given and what I'm trying to prove. When I'm given two congruent triangles, I have the ability to use a very powerful postulate, right? And that is corresponding parts of congruent triangles are congruent. All right, corresponding parts of congruent triangles are congruent. Very, very powerful. This allows me to identify up to 6 different parts of triangles that can be useful for me. So here I'm trying to find 2 different parts. So remember when I'm trying to identify triangles, I need 3 different parts of those triangles to meet one of those 5 different postulates. Side angle side all the way through hypotenuse leg. Right? So what do I have? These 2 red triangles, what components of those triangles do they have in common with the 2 green or the 2 purple triangles? Well, the red and the purple sides overlap here, right? So these 2 sides overlap, so those have in common. And then I have these 2 angles that overlap, right? You might say that this side overlaps. Well, it's not the entire side. This entire side for KZ is the entire side of the purple triangle, right? So it's just these 2 angles, KYT, are shared by both triangles, right? KYT are shared by both triangles, and line segment KY is shared by both triangles, right? And I can say that these 2 triangles, these 2 line segments are congruent, and these 2 angles are congruent because of corresponding parts of congruent triangles are congruent, because these are corresponding parts of congruent triangles, or you can say they're their counterparts if you want to, right? So I'm going to say angle YKT is congruent to angle HKT, and that line segment KY is congruent to line segment HKH. These corresponding parts of congruent triangles are congruent because these 2 red triangles are congruent triangles because that was given. Therefore, these 2 lengths and these 2 angles are congruent. And these 2 are going to help me prove that the purple ones are congruent. Now the only one that I have 2 sides, 2 angles. So now I need like another angle or another side. I could use these, I have no evidence to support that those are congruent, or I have to really work for those ones. I have these, right? I have no evidence to really support those two. But if I remember my good old friend, the reflexive property, right? Something is equal to itself when you have two triangles that are back to back and they share a common side. I can always say that that side is equal to itself. So line segment KZ is congruent to line segment KZ, right? And that's because of the reflexive property. Reflexive property of congruency. Okay? So now I have, this would be 1, 2, this would be 3. Okay? So now I have two sides and an angle in between. So side, angle, side. So now I can say that triangle YKZ is congruent to triangle HKZ because of side, angle, side. Okay, that's the first one. Pausing to flip. Alright. Next one I have is that these two lines are parallel. Is it these two? SP and YK are parallel. So whenever I'm given that two lines are parallel, I'm always looking for a transversal. Always. And the associated angles for a transversal. I'm given that the midpoint of SK is M. So I'm given that the midpoint of SK is M. That means that these 2 points in between SK, SM, and MK are congruent. Okay, so that these two are congruent. So that gives me 2 already. Okay, so those are the 2 things that it gives me. So I'm just going to go ahead and write those 2 down. SP is parallel to YK, and M is midpoint of SK. SP is parallel to YK. I don't know if I said SK. Alright, so this is the given statement. Given. So I'm going to say, I wrote the givens down in purple. Alright, so now I'm going to say in red what I deduce from that. So I'll say that line segment SM is congruent to line segment MK because of the definition of congruency. I'm just going to spit that out there. All right, go ahead and write that down. Okay, now it's asking me to prove that RMS and EMK are congruent. I'm trying to prove that those are congruent. Okay, and it gives me this transversal. Right? Give me this transversal. I could use this transversal, right? But this any angle that I have is interrupted with like for these triangles is interrupted by this pesky line segment, right? Because it would be this one or this one and this one, because it has to go from the transversal to the parallel line, right? So anything that would help me with these ones here is interrupted. But I can go ahead and chase over. Remember that I can always try to prove that congruent triangles, I can always try to unlock a congruent triangle, especially if those congruent triangles are adjacent to the triangles I'm trying to prove. Okay, if you have a transversal, right, and it doesn't help me prove the triangle I'm trying to prove, but those triangles are adjacent to other triangles that I can prove those triangles that are adjacent to the triangles that I'm trying to prove, and then once you unlock these triangles, you can unlock the triangles next to them more than likely. Okay, because you can unlock a bunch of sides and probably some angles next to them as well. Okay, so but before I do that, look what we have at every intersection ever. every intersection ever, we have vertical lines. Every section ever, we have vertical lines, right? So vertical line, or sorry, an intersection, yeah, we have vertical angles. Vertical angles. So we have these vertical angles, and then we have these vertical angles. Okay, so we have angle SME. Angle SME is congruent to angle KME, and angle SMR is congruent to angle KME. Wait, hold on. SMR is congruent to KME. Angle SME is congruent to SMR. KMR. So SME is congruent to KMR, and then SMR is congruent to KME. Sorry about that. KME. Alright, so these two are congruent. These are my double angles. SMR are my SMR is my double angle. KME is my double angle. SME is my single angle. And KMR is my single angle. Okay, all right, and this is because the vertical angles are congruent. Okay, those are so far. So now I have, for both of these, I have a side and an angle. All right, so now I need to prove an angle and a side, or an angle or a side for both of these. Right. I can't say that these are congruent because of the midpoint, because it didn't say that this was the midpoint for these two. Right, but I do have this transversal here, and I do have the line from here going to the transversal. I do have the angle going right from the transversal to the parallel line. Right from the transversal, the angle right from the transversal to the parallel line. Right, so these are interior angles, right, of that transversal. So I can say angle KMR, or KRM, angle KRM is congruent to angle SEM. Angle SEM, because vertical angles are congruent. Okay, now I have for this triangle and this triangle that they're congruent. Okay, because triangle KMR is congruent to triangle SEM because of we have a side, and we have two angles. I'm going to do this. Okay, two angles. We have an angle, and a side. Right, angle, and a side. Alright, so angle, side. Angle, side. It skips a side. Okay, that's breaking the pattern. So that's angle, side. So now that these two are congruent, I can use, let me skip to purple. I can use C, P, or congruent parts of congruent triangles are congruent. C, T, C are congruent. Okay, so I have this and this. Right, and I can say that this triangle onto this angle is congruent to this angle. Doesn't really help me, right? Unless I wanted to do some like crazy supplementary angle stuff, and I could do that, right? I could do the angle addition postulates and do a bunch of crazy math and stuff and do that, but I don't need to, right? I can also say that this line segment is congruent to this line segment, right? Because these are line segments shared by the same triangle. So now I'm going to say that line segment RM is congruent to line segment ME, or EM, if you want to be technical, EM, because CPCTC. And now I have these two triangles, which are my triangle RMS is congruent to triangle EMK, MK, because of the side angle side. Side angle side. Side angle side. Okay, so moving on to the next one. All right, so for this one, we just follow our 6-step method with a little bit of a tweak. It doesn't really tell us what the pattern for congruency is by naming the polygons, but it's pretty obvious how this is. It's kind of a reflection. So this one is S, this one is C, this one is L, and this one is V. Okay, and it tells us that these are what they represent, right? So B is to hotel, and these are the distances for each of these. Okay, so C to L, right? I'm just going to kind of do this to make it easier for us and ignore all the extra stuff because it's just the first letter of all these things. Okay, because they just do that to kind of make you transpose things and make it a little bit harder for you. Video, and you just interrupted it.
Are you having? Look, there's kids in here too.
That's fine. They can work off their stuff. Yeah, that's fine. So then you need to take all these and fill in their congruent counterparts. So 5.7 is 5.7. This is 6x minus 2.8. And then this would be 2x plus 3. And then this would be 6x minus 4.5. And then this would be 5x plus 2.7. Okay. Then you need to see what path they took. I'm going to take a look at this and think on it for a second. All right, so she went from the bakery to the hotel, so that was 6x minus 2.8. Then, I guess the whole perimeter is what she took. Where she started? Let me take a look, see here. Must have been the whole perimeter. That's I'm probably overthinking it. So it's probably just going to be, let's probably add it all up. So 2 times 6x minus 4.5. Then 2 plus 2 times 2x plus 3. Then 2 times 5x x plus 2.7. Yep. Then 2 times 5.7. And then 2, banana paper. So 2 times 6x minus 2.8. That's going to be equal to 76.6. All right, so time to number crunch a little. All right, that's going to be 12x plus 4x plus 10x plus 12x. All right, and we're going to have negative 9 plus 6 plus 2.7 times 2 is 5.4 plus 2 times 5.7 is 11.4. Did I do the 12x? Looks like I did do the 12x. Yeah, I did. I just didn't cross it out. Okay, and then minus 2.8 times 2 is 5.6 equals 76.6. Alright, I'm going to add everything up. Let's see, that's 24 plus 14. 24 plus 14 is 38x. 38x. And then we got, let's see, 9. This is a weird calculator that does syntax. No, okay, negative 9 plus 6 plus 5.4 plus 11.4 minus 5.6 equals 56.8 plus 56.8 equals 76.6. 38x equals, gotta subtract 56 from both sides. I don't think this is gonna be right. We have to check it. Okay. Let's see. Make that negative. Right, so 76.6 divided by 56.8 is going to be 1 point. It's like 1.4. 1 point is so x equals 1.4. Yeah, so what was that? 76.6 minus 56.8. That was like 19.8. 19.8. I'm going to pause and check that. Alright, so I made a little math error here. This actually equaled 8.2. 8.2 right there. So 8.2 minus 76.6 minus 8.2 equals 68.4. 68.4. Oops, should not have done that one. That equals 68.4. 68.4, 76.6. So then that divided by 38 equals 1.8. 1.8, and that is the correct answer. So just typed the numbers in wrong when I was typing them in my calculator, and that equals 1.8. Okay, so if you go back and you type these in here, that will equal 76.6. And so you can go back and check all this stuff. That's what I did, and I figured out that it wasn't correct. So I was like, well, what did I check my math? And usually it's when you're punching in the numbers in here. So there's that one.